All right, y'all. I hope everyone is finding themselves well. We have two things to learn today on this topic. Okay, so the first is area of regular polygons. Okay, now the first thing we need to understand is this word regular. Okay, I believe we have gone over it early on in the year, but what it is essentially regular is two different things. Okay, it is when you have all angles congruent of a shape, okay, and then all sides congruent in a shape. Okay, so it's those two things. It's essentially shapes that look like this. Okay, think about it like a triangle. Well, if you had all the same sides, okay, and then all the same angles, okay, that would be a regular triangle. Okay, a regular quadrilateral is everyone's favorite shape, a square, right? With the same thing, you've got all the same sides, and then you've got your right angles in here. Okay, or we could take it to the next length, which would be a hexagon. Okay, now not going to be perfect, all right, but a regular hexagon looks something like that. Okay, now again, all the same sides, okay, and then all the same angles. Okay. All right, so that's what regular shapes are. They look like that, and that's what we're trying to find the area of. Okay, now the formula, okay, is actually very simple. Okay, you just apply this formula. Okay, now we could talk about where it comes from, but we're not going to do that today. All right, but we've got the area equals 1/2, okay, times little a, all right, and then times big P. Okay, so what these two things, or what really all three of these things stand for, okay, this is area. Okay, you've got 1/2. Okay, now what the little a is, note the difference. Okay, you got big A and you got little a. Okay, little a is something different than the area. Okay, so when you see little a, we are now going to be referring to the apothem. Okay, now it's a weird word, but that's what it is. Okay, so it's the apothem. All right, and then this over here. Okay, we should be familiar with this. Okay, this is the perimeter. Okay, now when you have both of these things, when you have the apothem and you have the perimeter, well, the formula is very easy. Literally just 1/2, whatever the apothem is, times whatever the perimeter is of these shapes, right? So the perimeter, right, would just be, if you know one length, right, you just multiply by however many sides you have, right? So if this was a length of 1, let's say you got 1, well, you got 5 sides, okay? So it'd be a length all the way around of 5. And so that would be the perimeter. Over here, right, again, you just add up the lengths around and then add up the lengths around. Okay, but let's talk about the apothem. Okay, so the apothem, I'm actually going to go ahead and do that in purple. I don't know if, hopefully you'll be able to tell the difference between it when we're actually looking at it, but it's the purple apothem. Okay, so here is the apothem. It is this length right here, and it's always going to be perpendicular. Okay, it's always going to be perpendicular. Again, you go from the center, okay, and you connect straight down with a right angle. Okay, and you go again from the center and you connect straight down to form a right angle. Okay, now we're going to look at two different examples of this. One's going to be relatively simple, and one you're going to have to get a little bit creative in order to find out what's going on here. Okay, so again, the apothem is these lengths connecting from the center straight down. Okay, connecting with a right angle, perpendicular. Okay, center straight down, connecting with a right angle. That's the apothem. Okay, and again, if you were to know this length, right, if you're given that in the problem, you plug it in. And if you're given the perimeter, you plug it in. And it's relatively simple. Okay, all right, so we're going to look at two examples. Like I said, the first one's going to be the easier one. Okay. All right, so the first example we're going to look at is going to be in with a triangle, okay? And let's go ahead and draw the triangle, okay? And we're going to be given these various different lengths, okay? We're going to be given that this length is 12, okay, times the square root of 3. And then we're going to be given this length right here is going to be 3. Okay. All right. So we're going to be given that length is 3. Okay, so the formula. Okay, well, it's 1/2. Area is equal to 1/2 times the apothem times the perimeter. Okay, well, so let's look and see if we have, these two working parts. The apothem. Okay, do we have the apothem? Well, yes, that's connecting from the center, straight down, right angle. So that is my apothem. So we're good on that. Okay, question is, do I have the perimeter? Well, remember, these are regular shapes where all 3 sides are the same. So if this is 12 times the square root of 3, so is this. Okay, and then so is this. Okay, so we add up these 3 different lengths. Well, that's going to give me 12 plus 12 plus 12, and then you plop on that square root of 3. So the perimeter, just to show you, okay, the perimeter is going to be 36 times the square root of 3. Okay, so let's go ahead and plug it in. Here we go. So the area is equal to 1/2, okay, times the apothem. That length is 3, and then times the perimeter, which is 36 times the square root of 3. Okay, and then we just plug it in. Okay, so we've got, we've got the 1/2. Okay, so 1/2 times 36 is going to give me 18. 18 times 3 is going to give me 54. Okay, so 54 times the square root of 3 is my answer. And if we wanted to round that, we could use the calculator, and we are going to get about 93.5. Okay, so approximately 93.5. Okay, so that's the easy example. The reason it's easy, okay, is because I know the apothem, and the perimeter was very easy to find. Okay, so now we're going to talk about a harder question, and this is going to be a little bit of work. Okay, so make sure you're locked in, folks. Okay, all right, here we go. Okay, so this time, let's say we have a pentagon. Okay, we've got a pentagon. I think earlier in the video I called the pentagon a hexagon, but I don't know. Okay, 5 sides, pentagon. Okay, all right, so this time, all we're going to be given, okay, is we're going to be given that this length is 3, okay, connecting this right here. Okay, that's all we're given. Okay, now, again, the formula is 1/2 times the apothem times the perimeter. Okay, I don't have either of these. Okay, I don't have the apothem or the perimeter. So I've got to go find both of those. Okay, well, let's just talk about our goal here. Okay, our goal, well, let's just talk about the apothem. The apothem is right here. That's this length right here. Okay, so I now have that's one of my goals is to find that length right there. Okay, the next goal is to find the perimeter. Well, if only I knew these lengths. Remember, they're all the same. Okay, don't forget that these are all the same length. Okay, so that's my second goal is to find that perimeter. Well, in order to find the perimeter, that just means I need one length. Okay, because if I find 1, then I just multiply by 5 to get the perimeter. Okay, well, in order to just find one length, well, we actually know that these two are the same. So we end up only needing to find this length in order to get the entire perimeter. Okay, so now my 2 goals, okay, are to find this length right here. I'm going to go ahead and call it X, and then this length right here. Just this length, okay? It's just this part right here is that Y. Okay? So those are the 2 lengths we're trying to find because, again, those will help us in finding the apothem. Well, X is the apothem, and then the perimeter, Y, will help us find the perimeter. Okay? So now our kind of game plan here is this triangle becomes extremely important. Okay? Because that triangle has everything we need to know in it. Okay? So we're going to kind of lock in on this triangle right here. All right? And I'm going to go ahead and, let's see. I'm going to go ahead and put it right here. Okay? It's going to get a little bit hectic. Okay? But we're going to make this work. Okay? So I'm focused in on that little triangle right there. Now, turns out, right, again, since this is a regular polygon, okay, that means all your angles are the same. You can also kind of split up this nice shape, this pentagon, into, well, 5 separate parts, right? You've got this triangle right here, okay? And you got this one, this one, this one, and this one, okay? Now, we know that if you go all the way around, okay, you've traveled 360 degrees. Well, let's just focus in on just this right here, Okay, just that part is 1/5 of 360 degrees. Okay, so in order to find, just this angle right here, okay, we're just going to do 360 divided by 5, okay, which ends up being 72. Okay, so that angle, this entire thing, now it could be here as well, right, is 72. Well, 72, and if we're just looking at the red triangle, okay, well, just that red triangle, that little portion right here is just going to be 36. Okay, so that's what we'll go ahead and fill in right here. I'm going to make this triangle a little bit bigger. Okay, so this angle we now know, okay, to be 36 degrees. Okay, and again, the only other part we know is that this length is 3 right here. Okay, all right, so now brings us to what we call, well, we've done a lot of stuff with right triangles this entire year. Okay, right back in like February. Okay, and that's where we're at on this problem now. Okay, because now my goal is to find x and y. Once I find x and y, it's relatively easy to get those two parts. Okay, so let's talk about how to find x. All right, well, let's just work with x right here. Okay, x, all right, well, we notice that x is the length, well, when compared to 36, it happens to be my adjacent side. Okay, when compared to 36, happens to be the hypotenuse side, right, for that 3. Okay, so it brings us back to trigonometry, okay, in order to actually find this length right here. Okay, now I'm going to tell you now, depending on the problem, right, we happen to have 5 sides in the pentagon. Okay, this angle, right, that angle, that 36, will change depending on the problem. Now, if you run into a 30, 60, 90 triangle, feel free to use that. Okay, if you run into a 45, 45, 90 triangle, feel free to use that. Okay, but in this particular one, we have to use trigonometry. Okay, so let's talk about how to find x. Well, we know the relationship. Okay, this is my adjacent, right? Adjacent, hypotenuse. Okay, and so we've got to use, well, again, it should be a reminder of SOHCAHTOA. Okay, so we've got to use that in order to help us actually get this information. Okay, so we've got to use cosine here because I'm looking at the adjacent and the hypotenuse. So cosine, okay, of 36 is equal to x over 3. Okay, so from here, we're just going to multiply both sides by 3. So in other words, x is about, okay, 3 times the cosine of 36. Okay, so that's my x, and then we can put that into the calculator. Don't forget to put your calculator into degree mode. Okay, so it is 3 times the cosine of 36. Okay, it should get you about 2.43. Okay. Okay, 2.43. All right, so just because this is going to get a little bit crazy, that 2.43, don't forget what it is, okay? It was x, which happens to be the apothem. So let's go ahead and write that a is equal to 2.43, okay? Because we know we're going to use that later on when we plug it back into this formula up here, okay? Now, we've got to find y, okay? So let's focus in on y. Well, it's going to be a very similar process, okay? We're going to have to use trigonometry again, okay? So I'm going to go ahead and erase this trig work over here. Oh, we need that 3. Okay, but now my goal is to find this y right here. Well, again, we're going to compare it to that 36. Could you compare it to this one as well? Sure. Okay, but we know the 36, so there's no reason to work with that one. By the way, it's 54. Okay, but let's go ahead and compare it to that 36. So compared to 36, this side is the opposite. Okay, and then this one remains my hypotenuse. Okay, so this time, now we're going to use sine. Okay, so sine of 36, okay, is equal to y over 3. Okay, now again, since 3 is on the bottom, okay, you have to multiply by both sides by sine of 36. Remember that part varies. Okay, so y, okay, is equal to, oh, come on now, 3 sine of 36. Okay, and it should get you about, let's see, 3 times sine of 36 this time is going to get you about 1.67. Okay, so y is about 1.67. Sorry, 76. Okay, y is about 1.76. Now I'm going to go ahead and just to remember it, write that over here. Okay, so y happens to be about 1.76, and we're just going to round it. Okay, so now I have my y, my x, and again, that red triangle, super important. Okay, so let's go and now try to actually plug it into the formula. Okay, we don't need any of this. Okay, so I have my apothem. Okay, it's that 2.43. That's what we're literally going to plug in up here. Let's talk about the perimeter. Okay, this little section, remember it's just this section, okay, is 1.76. Well, let's think about how many of those we have. Okay, well, if I was looking at this entire length, okay, I've got 5 of those. So in other words, we have 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. Okay, so I'm going to go ahead and multiply that by 10, so therefore my perimeter is 17.6. Okay, now I have these two parts, and we just plug it into the formula. Okay, so I've got A is equal to 1/2 times my apothem, which is 2.43, times the perimeter, which is 17.6. Okay, and that you can put directly into the calculator. In this particular example, you are going to get 21 point, I'm going to go ahead and round, 21.4. So it's about 21.4. Okay, and now we rounded at a few different spots here, so just keep that in mind. Okay, so yes, it's complicated, but if you were good at trigonometry, if you were good at, if you're good at understanding what's going on here, right, with the angle, that angle in the middle, and understanding that how important that triangle is, you should be okay. All right. Now those are hard. All right, but we can manage it. Okay, so that's area of regular polygons using the apothem formula. Okay, now let's go ahead and talk about the second thing. Okay, and that is area of composite figures. Okay, now let's talk about this word composite. Okay, composite, right, to compose is to put something together, right? Think about a composition book, right? Bunch of pages together, or just a composition in like music, right? You're composing a piece. You're making a piece of music. Okay, that's exactly what we're doing, but just with shapes. Okay, that's what the figures part of that is. Okay, so let's say we had a shape like this. Now, these types of problems are going to depend on what you're given and what you have. Okay, this is not a difficult concept. It's just sometimes it's hard to see. Okay, so let's go ahead and draw this figure right here. Okay, something like that, and then a triangle like this. Okay, so let's say my figure looks something like that. Okay, well, we know a few different things here. Okay, all the new work I'm going to go ahead and write in red with this problem. Okay, this is just going to be everything that's given. Okay, so this is 6.06. We're going to say that this length is 7. We're going to say that this length is 3. We're going to say that this length is 7. And that's all we have. Okay, now notice we have 3 shapes in here. Okay, and that's what composite figures is. It is putting together different shapes and then trying to find the area of a funky looking figure based on the area, using the formulas that we already know. Okay, so the area of this, well, we're going to break it into 3 different parts. Okay, I've got a rectangle right here. Okay, rectangles, areas, very simple, base times height. So this area right here is just going to be 3 times 7, so it's 21. Okay, and I said I was going to do that in red, so let's just go ahead and put that right there. That is my area. Okay, now for the triangle. Okay, the area formula of a triangle. 1/2 times the base times the height. Okay, so relatively simple formula. If you know the base and you know the height, very easy. Okay, you've got 1/2 times the base. That's just going to be 7. And then my height here happens to be at 6.06. So luckily we're given it in the problem. Okay, so that's what we're going to put here, and we are going to go ahead and get that value. Okay, so 1/2 times 7, and then times 6.06. Okay, you end up getting 21.2. Okay, so let's go ahead and put 21.2. Okay, 1/2 times the base, and then times the height. Okay. All right, now this little section right here, well, it's not the world's best drawn thing, but it should be exactly half a circle. Okay, so we learned the area of a circle last time, or not that long ago. Okay, well, that's just this formula. Okay, right? You've got pi times the radius squared. Okay, so once you know the radius, very simple. Okay, but notice that this is just half of a circle. And I can't double count, right? If I were to find the area of the full circle, I'd be bleeding into this. Okay, so I've just got to make sure I divide by 2 afterwards because it's the area of a semicircle. Okay, I've got to plug in my computer. Otherwise, I'm going to lose progress. And that would be tragic. Okay. So, the radius. Okay, let's talk about the radius. Well, this, okay, let's look at this part. That is the length of 3. Okay, the diameter of this circle is 3. Okay, but my radius, so the diameter is 3, right? But the radius is half of that, which is 1.5. Okay, so now we can just plug it into the formula. Okay, we've got pi, okay, times the radius, which again was 1.5 squared. And we've got to make sure to divide by 2 afterwards. Okay, so again, we can put that into the calculator. Make sure you do the 1.5 squared first, right? You have to do that first. So you have to do the 1.5 squared, right? You got to do that part first, get that 2.25. Then you're going to multiply by pi. Okay, and then since it's a semicircle, right, half of a circle, I'm just going to divide by 2. Okay, so for this particular one, you're going to end up getting that 3.5. We'll go ahead and round to 3. So 3.53 for the area there. Okay, so that's finding each piece. Now in this particular one, we're adding everything, right? Imagine that, what if this circle was, what if, you're just trying to find the area of the shaded, right? Maybe you have to subtract. Okay, you're going to be adding or subtracting various different areas for composite figures. Okay, but you're going to use the formulas that you already know. So essentially it's just putting things together. Okay, so now we just got to add up. You've got 21.2, you've got 21, and you've got 3.53. Okay, so you got 21.2 plus 21, okay, and then plus that 3.53. You should get 45.73, and you will go ahead and leave it like that. So this is my area, 45.73. Okay, now obviously we cannot cover, I don't have time, no one has time to cover every little example for composite figures. Okay, so you got to get a little bit creative sometimes, but you will always have enough information to find the area. Again, you're going to be either adding multiple different figures together, or you may end up subtracting, just depending on the problem. Okay, all right, that is it for today.